Okay, so skill 9 was applying sinusoidal functions. So for this skill, we had to choose a city in the northern and eastern hemisphere. So I chose Beijing, which is in China. And then we had to choose a city in the southern and western hemisphere, and I chose Buenos Aires, which is in Argentina. So the objective of this problem was to create a sinusoidal function modeling the hours of daylight for each of the cities. So in order to create the sine function, I first had to list out the daylight hours in each city during the 4 months of March, June, September, and December. And this kind of like represents, like the spring, summer, fall, and winter. So I listed out the number of hours of daylight in each of the cities for the respective months. And then I graphed them on a coordinate plane, and I created my sine function. So to create the sine function, we need to know what our basic amplitude, period, shifts, etc. are. So the amplitude, otherwise known as the A value, is basically the height from the center line, otherwise known as the midpoint, to the peak or to the trough. So usually I just take the distance between the highest and the lowest point and divide it by 2. Therefore, for Beijing, the amplitude would be 2, and for Buenos Aires, it would actually be -2. And this is because the graph goes downwards first. So although they're equal in magnitude, the key difference here when we're like comparing and contrasting the graphs is that in Buenos Aires, like it's the amplitude is a negative value because of the fact that it goes down first. And the vertical shift is simply the midpoint, which in both cases is 12. So that's why we have that plus 12. Lastly, in order to determine the period of the functions, we must take into account the intervals of our graph, which represents a span of 3 months. Because we're representing a full year's worth of time, we must account for all 12 months, which is why we set the period formula equal to 12, and we end up with our period being pi over 6 times x. And so therefore you can see that like the sine functions are very similar for both of these graphs. However, like one really key difference is that this one has a negative amplitude. So now moving on to like the analysis of the graphs. So they're both equal in magnitude and they both have the same frequency because they both follow a yearly cycle, and that's the plus 12. I used and made like 2 sine graphs because I started at the equinox. However, you could make this a cosine function if you started at the solstice. Now when we're comparing like the domain and the ranges, they both have the same domain, which is -infinity to +infinity. However, and the ranges are the same in this case actually because they both range from 10 to 14, and that's because they have the same y value for the lowest and the highest point. There are no x-intercepts because it never crosses the x-axis. And then the y-intercept for both is actually 0, 12. When you put in 0 for both of these graphs, or like when you're solving for like the y-intercept as I show here, when you put in 0 for both, since the sign of 0 is just 0, that makes this entire thing 0, so you just have plus 12 at the end. So that's also when you like solve for the y-intercept algebraically, you can see that they both have the same y-intercepts. And then similarly, if like you were looking at the positive and the positive and the negative intervals, the positive would just be -infinity to +infinity for both of the graphs, and there would be no negative like interval because it never crosses below this axis. And that's comparing and contrasting skill 9.